Here we have 2x over 3 multiplied by 6y over 5. Just like reducing fractions, we can look for what is common in a numerator and in a denominator. As long as it is one numerator with one denominator, you're good to go. So let's look for what is common now. So there's nothing common between this 2 and 3. There's no common factor here between the 2x or the 3. And there's no common factor between the 6y and this 5. So seeing that I just checked the fractions vertically, let's check them diagonally. So 2x, there's nothing common with 2x and 5. But what about 3 and 6y? Yeah, 3 can go into 3 and 3 can also go into 6y. Let's do it. 3 into 3 goes 1 and 3 into 6 goes 2 times. Now pay attention. This 2x and this 2y, they're both in the numerator. So I cannot cancel anything that are in the same positions. Only a numerator with a denominator. So seeing that there are no other common factors between a numerator and a denominator, I can simply multiply across. So 2x times 2y will give us 4y or 4xy, because 2 times 2 is 4 and x times y is xy. Great. That's our numerator. With the denominator now we have 1 times 5, which is just 5. And that's it. Let's look at another example. We're going to work with x over 3y being multiplied by p over 2x. Let's check the fractions vertically. There's nothing common between x and 3y, and there's nothing common between p and 2x. We've done our vertical check. Let's look at the diagonal check. Oh, I see x is common with this 2x down here. So straight away I can reduce those. X into x goes 1, and x into this 2x goes 2. Seeing that there's nothing else that is common, I can just simply multiply across. 1 times p, that will give us just p. And we have 3y times 2. 3 times 2, that's 6. And remember, we had that y. Simple so far? Let's try another example. We're going to work with 6xy over 5 multiplied by 10x over 3y. Let's do the vertical check. Nothing common here and here. Let's look here. Nothing common here or here either. So we're going to have to go diagonal. So look, 6 and 3. I know 3 can go into both those numbers. So 3 into 6 goes 2 times. And 3 into 3 goes 1. And look at that. There's this y and this y. 1 y in the numerator, 1 y in the denominator. But that's not all. Do you see something else? We have 5, because 5 can go into 5 and 5 can also go into 10. 5 into 5 goes 1 time, and 5 into 10 goes 2 times. Great. Is there anything else to cancel? No. We cannot cancel this x with this x because both of them are in the same positions. They're in the numerators. So what we will have to do now is to multiply across. And you have to look carefully. This is where you can leave out some stuff. So we have 2 times 2, that's 4, working with the numbers first. Then we have x times x, that will give us x squared. Remember, this 2 is called the exponent or the index. It tells us how many times this factor is being multiplied by itself. So great, that's our numerator. In the denominator, we have 1 times 1, which is just 1. And to simplify this, anything divided by 1 is just that thing. So 4x squared divided by 1 is just 4x squared. Let's look at one last example. We're going to work with 12a squared b all over 7a multiplied by 21 over 30 b to the 5th power. Let's look for what is common. Straight away, I can see that there's an a that is common, but remember that this a squared means a times a. So I can cancel 1a out of the numerator with 1a in the denominator. Let's check 2. Oh, this b is common. I can cancel one of this b with one of these b out here. So I'm going to be left back with 4 b's instead of 5. Look 2. 7 can go into 7 one time. 7 can go into 21 3 times. 6 can go into 12 2 times. And 6 can go into 30 5 times. So I have to look carefully now at what is left. Because we cannot reduce any further, we now have to multiply across. We'll have 2 times 3, that will give us 6. So I'm working with the numbers first so that I don't get confused. I have 1a remaining in the numerator, so I'll put it back. And that's our new numerator. Let's look at the denominators. 1 times 5, that is 5. And I have b to the 4th power. Simple.